Welcome, dear student. In previous period, we discussed about different theorems. Theorem of internal division of chords and theorem of external division of chords. And another theorem is tangent secant segment theorem. We discussed in previous period. Today we will discuss about different examples on theorem of internal and external division of chords. Let us start. In previous period, we discussed about that tangent secant segment theorem. Here in first figure, chord AB and chord CD intersect inside the circle in point E. Therefore, by internal division of chords theorem, by that theorem, what we write? Multiplication of two parts of first chord, that is EC into ED, is equal to multiplication of another two parts of second chord, that is EA into EB. Here chord AB and chord CD intersect in point E outside the circle. Therefore, by theorem of external division of chords, by that theorem, what we write? First part, that is from E to first endpoint, EB into EA is equal to first part E to first endpoint D ED into E to another endpoint of chord, that is EC. Then tangent AB and secant CD intersect outside the circle in point B. Therefore, by theorem of tangent secant segment theorem, by that theorem, tangent segment, that is AB square, is equal to this intersecting point B to first endpoint of chord, that is BC, into from B to another endpoint of chord D, B to D, that is BD. In this way, we can use different theorem, different formulas. Here, first chord is AB and another chord is CD. Intersect inside the circle in point E. First chord is AB, another chord is CD. Intersect in point E inside the circle, then we can use different theorem. First is angle between two chords, that is angle E. Angle AEC is equal to 1 upon 2 into sum of intercepted arcs. Its intercepted arc is arc AC, measure of arc AC, plus its opposite angle is angle DEB, and its intercepted arc is arc DB, measure of arc DB. That is the first formula we can use here. If two chords, angle between two chords intersecting inside the circle, and another is theorem of internal division of chords. By theorem of internal division of chords, that is EA into EB is equal to EC into ED. Circle is given. First chord is MN, and second chord is RS. Intersect inside the circle in point D. Example is chord MN and chord RS. Chord MN and chord RS intersect at point D. There are two questions, sub questions. If RD is equal to 15, DS is equal to 4, MD is equal to 8, find DN. That is the first question. And second question, if RS is equal to 18, MD is equal to 9, DN is equal to 8, find DS. In solution, first example, RD is given 15, DS is 4, MD is 8, and asking question is DN. Two chords intersect inside the circle. Chords MN and another chord is RS. intersect inside the circle in point D. Therefore, by theorem of internal division of chords theorem, what we write from D to M, dm into dm into dn is equal to dr into ds. Dm, that is md, and here md is 8 into dn is the asking question, dr, that is rd is 15 into ds is 4. dn is equal to 15 into 4, 8 multiply, take on RHS side, it becomes divide. 4 1 is 4, 4 2s are 8, then 15 into 1 15 divided by 2, and 2 divided to 15, half of 15 is 7.5, and that is the answer. First answer we get here. Then here second example, that is RS is 18, MD is 9, and DN is 8. DS is the asking question. Here RS is the total length 18. DS is equal to X. Therefore dr is equal to what we get. If ds X and total length is 18, then dr is equal to what we get, total length RS minus that small length ds, that is 18 minus X we get here. Here two chords intersect inside the circle. Chords Mn and Rs intersect inside the circle in point D. Therefore, by theorem of internal division of chords, D to M into D to N, dm into dn is equal to d to r dr into d to s ds. Value of dm, that is md, is 9 into dn is 8. dr we find here 18 minus x. Int value of ds we suppose x consider 9 8s are 72 x multiplied to 18 18x minus x multiplied to x that is x square. Therefore, this minus x square taking on LHS side, it becomes plus x square, plus 18x becomes minus 18x, and on LHS side this is already present, that is plus 72 and is equal to 0. Minus x square plus 18x becomes minus 18x and plus 72. Then here plus sign on multiplication coefficient is 1 1 into 72 plus 72 we want multiplication and plus sign indicate factors addition, and factors addition we want middle term that is minus 18. 12 6 are 72 and addition we get 18. Minus sign for larger number, for addition signs are similar, therefore we write here minus, that is x square minus 12x minus 6x and plus 72 is equal to 0. Take common here x, then x we take common 1 times x remaining minus after taking common x only 12 remaining. Here small number 6 we can divide to 72, therefore we take common 6. After taking common 6 x remaining, plus sign changes because minus sign we take common, it becomes minus 6 divided to 72, 6 ने 72 ला भागायचा आहे, we get 12. 12 6 are 72. X minus 12 is common. In another bracket x minus 6, then first bracket x minus 12 is equal to 0, or second bracket x minus 6 is equal to 0. Minus 12 becomes plus 12 or minus 6 becomes plus 6. Therefore, ds we consider x, that is 12, then dr is equal to 18 minus x, 18 minus 12, that is 6, or ds is equal to we consider 6, then dr becomes 18 minus x, 18 minus 6, that is 12. Value of ds is 12 or 6. ds is equal to 12 or 6. That is the solution method. This is practice set 3.5, example number 2. This is tangent, and here secant intersect outside the circle in point P. PQ is the tangent and SR is the secant. Ray PQ touches the circle at point Q. PQ is given 12, PR is 8. Find PS and RS. In solution, what we write? Tangent PQ and secant SR intersect outside the circle in point P. Tangent PQ and secant SR intersect outside the circle in point P here. Tangent PQ and secant SR. PQ ही छेदी स्पर्शिका आहे आणि SR ही छेदिका आहे. त्या वर्तुळाच्या बाह्य भागात P बिंदू छेदतात. Outside the circle, वर्तुळाच्या बाहेर in point P. Therefore, by tangent secant segment theorem, by that theorem, tangent segment square, that is PQ square, is equal to what we write here. Tell here. Who can tell answer? PQ square is equal to what we write. PQ square is equal to, from intersecting point to first endpoint, that is PR, into from P to another endpoint, that is S, PS distance. Value of PQ is 12 given. 12 square is equal to value of PR is 8 into PS we find. 12 square, that is 12 into 12 we write here, is equal to 8 into PS. Therefore, PS is equal to what we write? 12 into 12, 8 multiply, take on LHS side, it becomes divide. 12 square means 12 we write 2 times. 4 2s are 8, 4 3s are 12, 2 1 is 2, 2 6 are 12. Therefore, 3 into 6, 3 6 are 18 is equal to PS, that is PS is equal to 18. That is the answer we get here. Another question is RS. RS is equal to, what is the formula? Total length PS we know here, minus that PS minus PR, then we get RS. PS contains two parts. RS is equal to PS minus PR. Value of PS is 18 minus value of PR 8 given here, and subtraction is 10. That is the answer. In this way, we can solve that example. Practice set 3.5. This is example number 1. O is the center given here. Here, secant and tangents intersect outside the circle. This OE is perpendicular to DC secant. AB is the tangent and DC is the secant intersect outside the circle in point A. O is the center of circle and B is the point of contact. B is the point of contact, means touching point. Segment OE is perpendicular to segment AD, that is given. AB is 12, AC is 8. Find first AD, second DC, and third DE. Here What we write? This that is tangent AB and second is DC intersect outside the circle in point A. The tangent and secant intersect outside the circle in point A. Therefore, by tangent and secant segment theorem, by that theorem, what we write? Tangent segment square, that is AB square, is equal to A to C into A to another endpoint D. Value of AB is 12 square is equal to AC 8 given into AD. 12 square is 144 is equal to 8 into AD. Therefore, AD is equal to what we write? 4 taking on LHS side, 8 taking on LHS side, 8 multiply, here divide. 8 1 is 8, subtraction 6 remaining, 64, 8 8 are 64, 18 8 are 144. Therefore, AD is equal to, we get 18, that is the first answer. Then DC, we find DC means subtraction of AD minus AC. AD is 18 minus AC, 8 given here, and subtraction is 10. DC is equal to 10, that is the answer here. And next question is DE. Total DC is 10. OE segment OE is perpendicular to chord DC. Therefore, from center, segment drawn from center to chord of a circle, then chord bisect the chord. Perpendicular drawn from center to chord bisect the chord. That is, two parts are congruent, means DE is equal to half of chord, that is DC. Half into DC is 10, we get 5. That is the answer. And reason is perpendicular drawn from center to chord bisect the chord. That theorem we can use here. In this way, we can solve that example. D is the asking question and its value is half of chord, that is 5. This is practice set 3.5 example number 3. The next example, first chord increase and second chord also increase and bisect outside the circle in point P. First chord is PS, second chord is RQ. Intersects outside the circle in point P. If PQ is equal to 6, QR is equal to 10, PS 8 given, find PS. Chords, first chord is PS and second chord is RQ. Intersect outside the circle in point P. Two chords intersect outside the circle in point P. Therefore, by external division of chords theorem, we can use here. By that theorem, what we write? From P to first endpoint PQ into P to second endpoint PR is equal to P to first endpoint PS into P to second endpoint PT. Here PQ is 6, QR is 10, PS is 8, PR we want here. PR is equal to addition of two parts. First is PQ plus second is QR, means 6 plus 10 and we get 16. Value of PQ is 6 into PR total length is 16 is equal to PS its value is 8 into PT. Then PT is equal to what we write? 6 into 16. 8 take on LHS side. 8 multiply. Here divide. 8 1 is 8. 8 2s are 16. That is 6 into 2 is equal to PT. Many students give good answer. multiplication is 12 is equal to pt is equal to 12, and asking question is ps by which method we find here? ps means total length pt minus ps, then we get ts. pt is 12 minus ps is 8, and subtraction what we get here? 4. Therefore ps is equal to 4. Practice at 3.5. This is fourth number example we discuss here. बरेच विद्यार्थी अगदी छान उत्तर द्याले. Dear student, today we discuss about different examples depend on external division of chords and internal division of chords and tangent secant segment theorem. You understand that different examples very well. The next part we see in next period. Thank you. आज जो झालेला तास आहे त्याचा व्हिडिओ आहे तो उद्या सकाळपर्यंत युट्यूबला अपलोड होतो. याच लिंकला तुम्ही टच करून पुन्हा पुन्हा बघू शकता and you will get more and more marks. Thank you. आज जो झालेला तास आहे त्याचा व्हिडिओ आहे उद्या सकाळपर्यंत युट्यूबला अपलोड होतो. याच लिंकला तुम्ही टच करून पुन्हा पुन्हा बघू शकता.